Welcome to Medicine 101 guys. So today basically I'm uploading the video regarding the beta oxidations of the fatty acids, and it's very important from the aspect of the biochemistry, and hope that after watching the video you'll have the better concepts and you will just understand the list, and you will understand the subject very easily, and you can remember also by just seeing the videos. I hope you will see the full video. And guys, one more request: if you are just new, you're watching for videos from my videos for first time, then do subscribe and comment. And if you don't understand anything, then you will comment of course there also. And let's start the videos. So there's the beta oxidation of fatty acids, guys. Beta oxidations of fatty acids. Now it's and let's suppose we know it only that because the thing that will happen within the mitochondria, within the inner membrane of the mitochondria, or you can say in the matrix here. So let's assume, let's figure out on for mitochondria. Let's consider like okay guys, and I'm considering it here. Let's consider like this only. Okay, of course. And see, this is the within the the mitochondria. This is the like mitochondria here. Okay, guys. And let's suppose this is the inner mitochondrial membrane here, and take it like this. Okay guys, I have done already. Now see, let's see what can we do here. Now we need to know basically what the the beta oxidations of the fatty acids is basically what that like the long chain fatty acid, the number of the carbonyl will be very high there. It approximate from 6 to maybe more than longer that. So I'm just assuming of fatty acids like this. I'm just considering the alkyl group here, CH2, CH2, C double bond O minus here. Okay guys, now what can I have here that, and let's consider this is the carbon number 16. Cn means carbon number equal to 16 here. Now here what will happen outside of the mitochondria, there what will happen here. Now see, there is an enzyme guys. A name of the enzyme, this is very important, you have to remember the name of the enzymes here. Okay, fatty acyl CoA synthetase. Fatty acyl fatty acyl CoA synthetase. Okay guys, by the hearing the name we are seeing that what one CoA group will add here. Okay, one CoA group will add here, and what will happen, and we have to utilize one molecule of ATP. That means what we have to spend the energy here. So we can say what the ATP that will break down into ADP plus PI. Now guys, now we will get what the ultimate product. We will get it at what the or CH2 C double bond O and CoA SH. Let's consider. Okay, and what's the name of the compound right now? That acetyl CoA. Okay, now you can think why are doing like this, because this the compound, this cannot take into within the mitochondria directly. Now we have to modify the compound, and we have to get this in terms of these conditions. Okay, now we have to know one more thing here. Within the mitochondria, in the membranes, there are some things. Okay, here let's consider one more thing here, and these things are called, this one is called the carnitine acyl transferase type 1. Carnitine acyl transferase type 1. Then what is the name of it? Carnitine acyl transferase type 1. Transferase type 1, and it is like what, Ca2 type 2. Just assume just 2, the same thing. Carnitine acyl transferase type 2. Okay, and this is 1. Now what will happen? Now from the carnitine type 1, these things will just act with this one. These things will act with this one. Okay, after that it will have the capacity to take into within the mitochondria. Of course, there are some channels, okay, through which the compound that will come within it. Okay, that will come within it. Now whenever this what the carnitine will act with it, then what will happen here? It will get converted into what? Fatty acyl, carnitine. You can remember that, you can write the name here. Fatty acyl carnitine. Fatty acyl carnitine. Now this fatty acyl carnitine is having the capacity to take entry within it. Now it will come within this channel within the mitochondria. Okay. Now we got within the mitochondria what? We got within the mitochondria fatty acyl CoA, fatty acyl CoA carnitine. Now there is a chance, guys, what this compound may go back to the again to the outside of the mitochondria. That's why we have to do something as if that it cannot go outside. So we will not let the compound to go outside. So we have to do one modifications here. There is one more thing what in the carnitine 2 you are seeing here. That's the thing. This carnitine 2 what he will do here, he will come here and he will cut this point and he will take the carnitine within it outside through the channel outside, and he is going to add what, one more CoA here. He is going to add one more CoA. That means what, acyl CoA. Okay, so it was not CoA, it was fatty acyl carnitine. It was name was fatty acyl carnitine, guys. Okay, not CoA carnitine. Now the carnitine type 2 will come here, then he will cut the junction in between the fatty acyl and carnitine, and the carnitine will be taken outside through the channels, and the carnitine type 2 I will add one more CoA here, one more CoA SH here. Now we'll get the compound what here? We'll get the ultimate compound, or CH2, CH2 C double bond O CoA SH. Now this compound cannot go back to outside. Okay, and guys already that this is the functional group from the basic concept what, they will form what, fatty acyl CoA again, and it is a functional group that ketone group, and it should be the alpha carbon, it should be the beta carbon here. Okay, it should be the alpha, it should be the beta carbon here. Now what we are having here, now we are going to do that this compound will get converted into another compound in the actions. Okay, and there is a series of actions here, and ultimately we get back again some things, the acyl CoA, and we will get back also the fatty acid. We will see how this step by step is going on here. Okay, let's see what can you do. Now there is enzyme, the name of the enzyme what, acyl CoA dehydrogenase. Acyl CoA, name of the enzyme acyl CoA dehydrogenase. Guys, whenever I am saying dehydrogenase, that means hydrogen is going out, hydrogen is removing. We are removing the hydrogen from the compound. Dehydrogenase. And that dehydrogenase will be taken by what, FAD, and he will get converted into FADH2. FADH2. Okay, FADH2. Now by the action of the acyl CoA dehydrogenase on whom, on the fatty acyl CoA, what we are going to have on the new compound. That's what, it will be like this structure I am writing in the, or there is like dehydrogenase. That means what, we are removing the hydrogen, and if we remove the hydrogen from a, first suppose I am just removing the hydrogen from this point, then what will happen, there will be the double bond, okay guys. Okay, I'm removing two hydrogens, so from here, so I'll get ultimate or CH, or I'm writing CH here. Okay, then double one C H double one O. Okay, then CoA SH. Now we have to name the compound. What we are seeing, the hydrogen, two hydrogens, they are locating in the opposite side of each other, so you can say this is the trans compound, not cis, because they are locating on the opposite side of each other. So we can see the trans compound, and the there is enoyl compound, enoyl group here. So what will be the name? Trans delta to enoyl CoA. What will be the name? Trans delta to enoyl CoA. Trans delta to enoyl CoA. Okay, and after that, what? One more enzyme will act on it. What is the name of the enzyme? Enoyl CoA hydratase. There is enzyme that will, that is the name of the enzyme, enoyl CoA hydratase. You guys, you can understand from by hearing the term that hydrogen means there should be something with water molecules. What will happen? It will add one molecule of water here. It will add one molecule of water here. Okay, the enoyl CoA hydratase, it will add one molecule of water here, and this, from the water we'll get OH compounds. So let's see what can we have in the next compound, and after modifications we'll get R C CH, and we'll get one OH component, because by getting the, by splitting the water as H plus OH minus, we'll get ultimately one OH here. Okay, and the double bond will be removed. Then what we are having? C, again right here, H, then C double bond O, CoA SH. Okay guys, and what will be the name of the compound now? It will be beta hydroxy enoyl CoA. Sorry, beta hydroxy acyl CoA. It will be beta hydroxy acyl CoA. Beta hydroxy acyl CoA. The name of the compound will be beta hydroxy acyl CoA. The name of the compound from here to here, it will be beta hydroxy acyl CoA, guys. Okay. Then the next steps of the reactions of the beta oxidations. What we are having here, this compound again will undergo another reactions. Okay, and the reaction is what? There is an enzyme that is called beta keto acyl CoA dehydrogenase. Okay, beta keto acyl CoA dehydrogenase. By hearing that term, that means what? There should be removing of hydrogen, and those hydrogen will be taken by whom? NAD plus, and NAD plus will get converted into NADH. Okay, now this, by the dehydrogenase, we can see what? This NAD plus will take the hydrogen, and it will get converted into NADH. Okay guys, now we are going to have in the next steps, what will be the name of the compound here? Beta keto acyl CoA, and we will have the compound in these terms, what? R CH2 CH2 C double bond O, and here CH C double bond O, sorry guys. So beta keto acyl CoA, what I was saying, that beta keto acyl CoA, and by the action of the beta keto acyl CoA dehydrogenase, the NAD plus, from here the hydrogen will be taken by whom? NAD plus, and it will get converted into NADH. Okay, and it will be in the terms of what? This compound that is called beta keto acyl CoA. And what will be the figure of this compound will be like this. I'm just writing here again. Figure will be like this only. R CH2 CH2 C double bond O. Okay, then CH C double bond O CoA SH. The figure will be like this only. Okay, you can just remove it here from here. Okay, now we will get the compound what? Beta keto acyl CoA, and of the name of the compound will be what? This compound will be beta keto acyl CoA. Beta keto acyl CoA. Okay, guys. And then what will happen? There is one more enzyme here. Okay, this is the final steps we can say. The name of the enzyme is thiolase. Thio means break. The function is to break. Okay. The next steps or the final steps we can say thiolase. And the enzymes will what? You will just add one molecule of what? CoA SH here. And its main function here, you will break the bond in between this. You are seeing it here. It's in between this bond. And you will come here and break this bond. So what? From this point, what we are going to have acetyl CoA. From here we will get what? Acetyl CoA. If we just consider CH3 from here, we will get acetyl CoA. And if we see, then we will get what? From here we will get again the the fatty acids. We will get again the fatty acyl CoA. From here the fatty acyl CoA, because this CoA SH group will be added with it. Okay, and this compound will itself will form what? The acetyl CoA. So we will get the two compounds, acetyl CoA, and plus we will get, because what did I say, this CoA SH will be added with what? With it, and it will form again what? RCH2 CH2 C double bond COSH, and it will form the same compound like this only. Again it will go through all the steps, and again it will get converted to acetyl CoA and one more compounds. Again the fatty acyl CoA again will come here. Again the cycle will be continued until the carbon numbers is not getting decreased at last. Okay. So the acetyl CoA, this compound will be what? This compound will be cycled through the TCA systems. There's like Krebs cycles, and it will produce what? It will go through the Krebs cycle, or you can say TCA cycle, and it will produce FADH2. There is NADPH, or you can say NADH, or it will produce ATP. Many things will produce it here. And what about this compound? I'm just writing it here. This compound, what it will form? RCH2, CH2 C double bond O CoA SH. This CoA SH is taken from here, and this compound will act as again will come here. Okay. So this was all about the beta hydroxy, the beta oxidations of the fatty acids. The brief part I'll just upload the next video regarding of these things, and in details whatever of the things and the calculations of the ATP in case of the origin fatty acids, in case of eventual fatty acids, many things are there. And what are the complications, and from the based of the aspect of the clinical points, what type of the disorders are here regarding with the fatty acid synthesis and the deposition in the body. Okay guys, see you in the next video. Stay safe.